Alright. So last class we talked about the inference, the rules of inference, and the purpose of why are we doing those inference from a very complicated stuff, propositional calculus, to a maybe simplified one. First, I give some example of the motivations that we are going to use this kind of inference. So we mentioned this motivations why we are using this propositional calculus and those inference to deal with them. The first reason we are using that is it can simplify. Right? It can simplify a lot so that we can see those propositional calculus more clearly with a very shorter expression that simplify. And the second one is allow us to remove the contradictions. So I give the example on the textbook, but I find out that this textbook example may not make a lot of sense to you because it's mentioning some certain system, so that's why we all got confused. Therefore, I come up with some another new example here so that we can better understand what is the actual contradiction there. Okay, if you have a textbook, it's on page 43. So the original example there is the system is in alert state only when it's waiting or intruder or practice alert. So since maybe a lot of students, we do not have a pre-knowledge of the maybe alert system, the teaching mode, the alert state, or something like waiting intruder. We do not have the pre-knowledge on that, so it might be a little bit hard to understand this. Where is the contradiction there? However, right now we can give you another example. Let's use the banking system as an example. Okay, so here, remember that here we want to show that there is a contradiction there. You can find the contradiction with the propositional calculus, but with the natural language it's hard. Okay, so the purpose is that, and the example is like this. Okay, so the first statement in natural language is the amount can be changed only when user withdraw the money and there are sufficient amount available. Okay, the amount can be changed only when user withdraw the money and there is sufficient amount. Okay, so the statement is like this: change amount will have the equality to user withdraw. Withdraw money and a sufficient amount. Let's see, amount available. Okay, and amount available. Okay, that makes sense, right? You can only change your bank account amount, balance, change balance. Let's see. Only when user withdraw the money and there are money available there. So if you withdraw the money and money available, you change the balance. If you change the balance, the user withdraw the money and amount available. Makes sense, right? Because it's only there. Alright, and then later on in another sentence it says if the amount is available, if the amount available and the bank charge the administration fees, then the balance will change. So amount available and bank charge the fees, we will know that it will result in the change of balance. Okay, change of balance. Later on, the third sentence is you can withdraw the money and sufficient amount will be there, and there won't be fee charged. So if you withdraw money, user withdraw the money and amount available. And not charge the fee. Okay. So if you see all the three sentences, expressions, every one of them will look okay, right? First is the balance will be changed. The balance will be changed only when user withdraw the money and there is sufficient amount available there. Okay. Second sentence is, right, the first sentence there's no problem at all, right? And then it says the amount, and if there's amount available and you charge, and the bank charge some management fees, then the balance will be changed. And third sentence is the user withdraw the money. The user can withdraw the money, and so this status can coexist. User withdraw the money. The system will allow the user withdraw the money and the amount available and not charge any fees. Okay, so every one of them is okay if individually. However, you put them together, problems come because you cannot set up equality of this part and this part. Then either this equality has a problem or this implication get problem, so that result in a contradiction. So there is a situation exists that if we given this three of them, a situation exists that that change balance implies user withdrawal and amount available is wrong, because there's also a situation that amount available and charge fee change the balance. Okay, and this part, amount available, also this user withdraw money and amount available, they are not equal. I mean, this part, there's no equality of this part, because here they cannot coexist. Only when user withdraw amount available and not change charge fee, this kind of three status exists. So there is a situation that like this. So you can withdraw the money, the amount is available, and you not charge any fee. That's the situation that I have enough money there. I can withdraw the money, and the bank is not charging any fee to me. Okay, maybe because I have a direct deposit or enough saving account, then bank it won't charge any fee. So that we do not have any situation that make amount available and charge fee with this user withdrawal and amount available equal, then yeah, a problem comes. So that's a contradiction which can only be detected here, but not in natural language. Okay. Alright, so this is some confusing point from last class, and another confusing point is here. that we're trying to say is things like if the inlet valve is open, then the system switch to open, and the outlet valve is closed if the monitoring system is functioning. This whole sentence doesn't make any sense if we are thinking following this description. So sometimes we have to describe with our own, with some example that is close to our life. So let's again use some banking system for this, right? Yeah. So let's say this: if a user has social security number, right, then the credit card can be approved. Make sense? That makes sense, right? And the credit line is 10,000, let's see, and it's 10,000 if the credit score is above 760. Okay, so for this statement, okay, it makes more sense than the textbook example, so that people won't get confused a lot. So if the user has SSN, then the credit card can be approved, and the credit line is if the score is 70, this one is above reach 760, and the credit line is 10,000 if the credit score reach 760. Okay, for this, everyone knows what this meaning, right? What's the meaning of it, right? However, somehow you can have two different understanding to this single sentence, single expression, right? First is SSN, have SSN, okay, then we know that have SSN and credit score rich, credit score rich. No, it's open. No, let's do this. Have SSN, then we approve card approved. Okay, have SSN card approved, and combine with the next sentence, card approved and credit score reached. If credit score reached, we'll have this credit line high credit line. Okay, just say this. Okay, so that's one transformation from natural language to this propositional calculus, right? If we have SSN, then if we have SSN, then you have your credit card approved, and if you have a credit score reached, then you have a high credit line. Okay, sounds good, right? However, we can have another understanding to it. Yes, if you have SSN, you will have if you have SSN, and if the credit score reached, you will know that we get this card approved, and high credit line. Okay, so according to this, just this sentence, all of them, both of them are correct. Okay, because you can think if you want get card, the precondition is SSN, right? The card is approved. However, since we are doing this here, and the credit line is if the credit score is reach something there. So two different understanding. First is if you want to have a card, the only condition is you have SSN. However, in this transformation, in this understanding, if you want to have a card, first you need to have SSN, then you need to have a credit score, like reach some point. Okay, so the problem here is for this card to be approved, you can have either just one precondition, or here you have two preconditions. Okay, and if you have this two precondition met, you can have card approved and you can have a high credit line. However, in this first transformation, you get SSN, you get card approved. Then upon that, if you have a credit score, high credit score, you can have high credit line, right? So it's there's some status that you can have a credit card approved, but not with a high credit line. But here in the second understanding, you can only have a credit card approved with a high credit line. Okay, so that's the issue here. Okay, just from this sentence, we can have different understanding. So that's called ambiguity. This is something maybe this book's example is not clear, but I want to make it clear so that we all understand everything here. Okay, all right, is it better than last time? Yeah, great. Okay, then simplify. Okay, remove contradiction, right? Remove ambiguity. Yeah, and it helps us to, with the simplified and non-ambiguous and non-contradict expression, we can have questions asked clearly to the customers and the team. Okay, so that's why it's good to use propositional calculus and to use this inference rules and make change there. Alright, so we were talking about inference rules. So let's go back here. Yeah, rules of inference. Alright. So let's a little bit review. So if we are trying to define some rule here, yeah, the thing you need to remember is it has 3 parts here. Each rule has 3 parts. First is the thing at the left side is the conditions and maybe the result, what can be implied. And also here we have the direction. In the middle is the direction. So it can be from up to down, or it can be down, implies the up thing. So here we have a equal sign here. So it means P1 or P1 makes P1 is equal to P1. And P1 equals to P1 or P1. Okay, so that's by direction. Both direction will work. And at the right side is the name of that inference. Okay, P1 or P1 make sense. P1 or true make true. P1 or false, it's make a P1. If P1 is true, it's true, right? If P1 is false, then it's false. They are all the same. P1 or P1 and P2 is the same as P1. We use as choose table to make it happen, right? Or here, P1 or P2. So yeah, so true, yes. And where are we last time? Somebody remember which one are we talk about at the end of the last class? That's okay, let's go through this. So P1 and the P1 make a P1 is both direction, because P1 to P1 and true P1. Oh, remember this, actually if there's no equal sign there, okay, there is no direction from, it's only one direction, from up to down. Okay. Here P1, P2, I think we talked about them already. Yeah. So it's easy. We can prove every single rule of it. But some of them is pretty common. It's easy to tell. But some of them is like associate. Those are similar to like when we're doing the times, things like that. So like here we can group the last two, or we can group the first two. This we can group the last two, first two. So that's pretty straightforward. But this one is something we want to combine this or and this and. So it becomes this or with P1, P2, and P1 or P3. However, we're not change this and. We're not changing this and. Yeah, so yeah, and this is the same. we're not changing this OR, but we put the P1 and P2 together, make it put AND, and P1 and P3, there's an AND, things like that. Okay. And here it's like we put the negation inside, we need to change. The only time we change this OR to AND is we put a negation. We put the negation inside, okay? And then we need to change this AND. And this is the same. We change AND to OR. This is we change OR to AND. So they're both, you can go up to down and down to up. Okay. And this negation, negation, we eliminate them. And P1 or negation P1, always true. So P1 and negation P1 always false. Make a lot of sense. And this implication, okay, P1 implies P2. If from P1 implies P2, we know that negation P1 or P2. Okay, so yeah, negation P1 or P2. We can prove that with those truth table. We can try different values, so it will result in this. And logically, if you think, if I'm here, we will have class, right? I'm not here, or we have class. So logically, it works, right? It's so two different situations here. And here it's the same, just P1 implies P2, another condition negation P2, it's a P1, it's a negation P1. So if both these conditions, we have two conditions, and then we have this result here. Also from here, this equality is P1, P2, their equality. You have equality here. We know that P1 implies P2 and P2 implies P1. So that's basically the definition of equality. And the exclusive disjunction, that's basically the definition of exclusive disjunction. Okay. Equivalent. Okay. So these are all the maybe rules we use pretty frequently. Some of them make a lot of sense here. However, some of them maybe you are not quite familiar. Okay, like this one. However, they are when you are doing the proof, you kind of need to find this inference there in order to make those proof, like or reduce some complicated propositional calculus to a simpler one. Well, this is a thing you have to practice, but yeah, I know it's not just a day thing, or sometime you can do those reduction or proof from your just intuition, but this will give you a solid proof if you can use this kind of inference rules to do the proof. Let's see an example of doing this proof. Okay. this one? Open or closed, and malfunction, or true, or open. No. Yeah. So, can anyone tell me the value of this?
What are the values of open, closed, and malfunction?
No, there's no value right now. If we want to reduce this to something, can anybody just tell me directly?
I would say true because it's all ors, right?
Yeah, okay. Yeah, from our intuition. Yeah, it is true. It is true because or true something. You may even make 100 like 100 false or true, or false or false or false or false. Still, you're gonna true because there's a true there, right? And it's or. However, if I want you to like make a proof of it from those inference rules, let's see if we can find something there.
That'd be distribution.
Think or true is that something? Yeah, this is similar, right? It's P1 or true makes it true, right? So this is similar to that. However, it just say P1 or true. However, we have a more than one operator here. More than one operator here.
Should we though? They're all nested in parentheses, so you can just declare the entire parentheses to be a parameter.
Yeah, even you doing this like here, we put it here, and you group them together. It's kind of, we still need to apply those association rule, right, to make them, put them together, right? So this is parentheses, there's brackets here. We can make them just like P1, but P1 or true or open, things like this. However, we do not have a rule that directly address that P1 or true or another thing. So we cannot just say that here. If you want to say that, actually, no matter how many P1 true, P2, P3, P4, P5, P6, if you use all there, there's a true here. But we are not specifying any rule like this. But if we want to do the proof that what we just said is correct, and we can maybe create a new rule there. But when we're doing the proof, we have to base our proof on this rule of inferences. That's rules of inferences. That's maybe it's already something in common and it's already mentioned there. We can create a lot of rules, but we need to prove those rules first. Okay. Yeah. The truth is more than these rules. You can have a lot of change, transformations from these rules, but we need before create any rule, we need to prove that rule is correct. So here, let's do this. Okay. So use a common sense. We know it's all true because we have logic. Okay, however, mathematically, if we want to prove it, we need to do this, and please pay attention to the format I'm doing this. Okay. Yeah, okay. So this PR refers to this whole propositional calculus expression. Okay, propositional calculus. Okay, and first it's here 1. What we do is according to this PR, and we apply, let's see, a comma and let's say what are those. So I'm gonna use these 2 rules of inference to apply them in here. So let's say what are those. First is common end, right? So it's basically it's P1 and P2 equals to P2 and P1. The other one here is okay, here. So P1 and bracket parentheses P2 or P3. We put them in P1 and P2 or P1 and P3. So let's do this. So we get this in here. Open. So it's we put this malfunction inside. All right. So it becomes let's see. So is this? Yeah. So P1, P2, we can change the order. If we change the order, because if we want to put the malfunction inside, the only rule we have right now is here. P1 and brackets P2 or P3, right? Here we cannot directly apply this rule because we have this brackets in front of these operands. So first thing is actually we move this malfunction to here. So there's malfunction and open or closed. No, we're not using this here because malfunction on maple closed. Right. Or true or open. If we only do one thing, apply one rule at the step, it will look like this. Okay. And then if we apply that, if we apply another rule to 2, it's and or and or. We apply distance this dist and or rule to number 1, sorry, to this number 1. Number 1 refers to this expression. All right, So number 1, we will have malfunction. Tell me what's the rest? Malfunction. If we want to put malfunction in, apply this and or rule. DIST. Dist.
So it'd be and.
Yep.
It would just be the same, wouldn't it?
And open.
Open or close.
No. It's open or malfunction. Malfunction.
Oh, I see. And then or.
Yeah. And close. Yeah. Yep. Then the rest of them, we are not changing anything here. Right? So it becomes something like this. Okay, and then number 3. Number 3, we must have something applied to number 2, right? Yeah, it's a common or. Common or 2. Let's see. Yeah, then we apply this rule. Com or. So if we look here, com or means we switch the order. Okay. So we can switch the order. That. If we want more strict, we actually want to group them. Yeah. We know that we can just group them if there's or there. If we apply this this rule here, association rule, we can just group them. We can group them. So here I will skip that because we're not. We know that we don't know that. I'm gonna skip it. So if we apply this common or, we can find out that close and malfunction and true. Yeah. So it's like if we group them, if we group this, right, and we apply common or rule here, and the yeah, okay, this common or rule, and the other rule is this so dist or and. Let's see, what is this? Dist or and. No, we're not reaching that yet, sorry. Or 2. So or number 2 is P1 or true become true, right? So here we kind of group this open and true. We put open in the front and true here. So we know that this expression is true. Alright, so it becomes something like this. Or true. Okay, it becomes main function and open, or main function and close, or true. And number 4. Or see. Yeah. Okay. Number 4, we apply something to number 3 here. And then we got this is yeah, this is confused. So yeah, I was trying to number 3 we use common or, and we use another thing, this and this, or and. Let's see, this rules, let me put this rule here so that put them side by side so that we can easily see them. Okay, so if we apply a common or, which is exchange the order and the just or and, yeah, just the or and, which basically says how do you put the outside or and make them inside this parenthesis. Okay, so basically we are doing this part. So we're trying to put this true. Yeah, we're trying to put this true inside. Yeah, put this true inside here, which make it become this. Still we keep the same, this part. Or then we put this true inside. What shall we do? How do we put this true inside according to this rule? Or and or, right? Or and or, right? We put this true inside, so it becomes this. True. No. Here we still have this. So we have this closed or true, right? And malfunction or true. Right? Because we put this true inside, right? We just put this or, combine the malfunction with the true. You use the or. Combine this close with true, with this or. Then it becomes something like this. And of course, if you want it to be more clear, you can let's group it. Yeah, group it. Okay. Number 5, we apply something to number 4. So we see that we have a bunch of thing here. Okay, we need to group it. Okay, here we know that this should be true, right? And this part should be true, right? So because first it's common sense, we know one or true is true, but we need to make it formally. So one thing or true becomes true, it's called or 2. It has a name. Okay, so we use this or 2. Right, we use or 2, which make it become this. We are not doing anything for this part, right? Because we only want to make this true become true. So now we are dealing with this close or true. It becomes true. Okay, so it's true, and this becomes true, right? Still or 2. This part, malfunction or true, becomes true. Or true. When we group them, it becomes true and true, right? And then number 6, we apply something to number 5, right? So can anybody tell me what shall we do next?
I think it's and 2.
And 2.
I can't see it. Oh, yeah. Okay, what did it say?
Yeah, we use basically and 1 or and 2, we can result in this and 1 or and 2. Let's do this anyway. And 1 or and 2 will result in this. And 1 or and 2 will make this true and true becomes true, right? So here it's the same. Come on. Malfunction, open and true. Right? Makes sense, right? And number 7, we are doing something to this expression number 6. So what kind of rule are we planning here? Let's see. Any idea? What do we do to here?
Would it be distribution?
Yes, we want to do the distribution. Yeah, exactly. So we want to use distribution. Yes, so that we can put this outside or into this inside, to inside. Okay. So it's gonna be distribution or and. Distribution or and means we put this outside or and this end. So distribution name, if you want to remember it, so the distribution or end. The first or is the thing outside. The end is the thing inside. Okay. Distribution or end. Then we actually put this malfunction or true. And this open or true. I actually omit a step, which is put the true to the front. Okay, I omit one step, right? So the distribution is actually if you have two operands here, it has to be the one after this or, the operands after this or. But here we put this two operands parentheses before this or. So actually here between 6 and 7 I kind of omit a step, like change the order of this true and this malfunction and open expression. So it's okay, it's something like common sense, although it's a rule, but we all know it's there. Okay, so then number 8, we're doing something to number 6 to number 7, right? So what is the thing? What is the thing? Malfunction or true. We want them to become true. We want this become true. We want this become true, right? So which one? Or 2, right? We use or 2 so that we got this true and true for sure. And number 9, we do something to number 7. Basically, if we apply the definition, of and, we can directly get this true. Yeah. Yes. Okay, so finally we get this true here. Yeah. So the thing I want you to remember is when you're doing the proof, you if you want to show it clearly, you kind of want to apply. Yeah, if you say like I apply this rule together to this very initial one, we can have this true here, but it's not as clear as we show it step by step. So when you're doing assignments, homework, we need to do it step by step. Okay, maybe you can say I'm gonna omit 1 or 2 steps which make common sense, so that's fine. Like when we switch the order, I just do not put a single step there, it's okay. But sometimes if you apply those rules, yeah, if you omit that, you can actually put them together, yeah, so that we can just read. I can just read it. I know you are making this change. Apply it there. Okay. All right. Actually, let's give in this same expression. Let me delete this whole thing. Okay, let's have some other way to prove it's true and make a shorter step. Can we do that? Ooh, just now we like use 8 or 9 steps, right? But here we can maybe we do something else. Can we do something else? Can we?
So if we're doing parentheses out, right? Wouldn't we use the definition or the maybe the distribution of and or for open and malfunction or closed and malfunction?
Yeah, then yeah, actually we can yeah, let's just do this. About number 1. Parenthesis, and this true. We just here we can group those two first. We maybe switch the order or something like that. So true and open, it can be grouped because we are using or here, right? Or, so we can basically group those two together, and then we switch the order. I can't remember which one is the switch the order. Yeah, common. Okay, so it becomes something like right. So then this becomes true. So this is what we apply something to the expression. It's the we change common or, and then we apply or to. Right. So it becomes this. Oh, we're not doing it here. Becomes true, right? Because we make this true, it's or 2 exactly. So that means we apply to 1 with or 2. Okay, and number 3. Number 3, it becomes another or 2 directly. See that? Because it's parenthesis. We don't need to, because it's just a bigger parenthesis here. We don't need to like distribute or something like that. So we can directly get it true. By apply or 2 to number 2 expression, right? So the important thing is here, you kind of want, although we know that P1 or true is true, reverse true or P1 is true, right? But true or P1 is true, we are not naming anything here. when we are doing the proof, we kind of want to use the thing that is available to us. Okay. Although we can actually have a lot of things that is true from here, but we restrict, when we're doing the proof, we restrict what is available to us to only this piece of sheet. Okay, this piece of paper. So when you're doing the proof, please use the rule here, use the inference rules here, and put them down here, name them, and explain exactly what have you done to number 1 is you apply this rule, right? So if you apply or2 to here, it becomes true. But before that, you have to kind of form that with the format given to you in this rules of inference. Okay, all right. So that's what we want to talk today, and we do have this proof template here, which may help you a little bit. So it's the same thing as what I did here. Like you name the thing, you kind of give a reference to it. Reference means what you have done. Like this one is reference, and you have this ID for everything, and you have a rule applied. Okay, so use this kind of template. Use this sheet to do the proof if you are doing the assignment. Okay, all right. Actually, we do have some assignment here. I will make them available to you since we just talked about the proof today. And okay, you will have until next week to submit this assignment. All right. Okay, thank you very much for coming today.